So how do we imagine this lightning? So I was thinking that so how do we imagine this lightning functioning? So okay, so we have our cloud up here. That circle. Interesting. I did not know you could do that. Oh yes. All right, so I'm going to use the line. Imagine this is the cloud, and so I want the lightning to kind of like jump. Oh boy, come on, guy. To jump like this, and then it will jump back, and then it will jump this way, and then maybe it will jump a little bit up, and it will jump a little bit down, zigzag like here, 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 here. This one goes up again here, 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 and then it will like hit the ground and stop. And then, so that's like one lightning rod, but maybe like it's split here into another line. Maybe it's split here too. Maybe this one's split as well. Here too. So how do we describe this kind of like drawing in code? Well, the good thing is there's a lot of random movement, and we know how to use random stuff. But let's kind of simplify it. Instead of thinking like, I don't know, I guess you could do a loop that just kind of cycles, but then how are you going to do these branches that might break into a random number of other sub branches? That would be a very complicated like for loop that we need to make here. So let's just simplify our life and like start at the beginning, and maybe we'll figure out how to like make it happen. So how do we describe this first jump? Like, this is a good representative jump. So we have a point here. We can kind of like dig out what that address is from the cloud, right? Because it's like a place on the sprite, and we already have cloud X that's kind of traveling across the screen. So we can like in the coordinate terms describe this location. So that's our starting point. And then we want our thing to sort of like pick a random point that is like in this basic zone, right? So we want to pick a random point, and in our case we're gonna pick here, and then we're gonna draw a line from our starting point to our other random point that we have selected. And so this random point, I feel, is mostly going to be down, but there's a little bit of an up opportunity. And so let's describe that in code, and then we'll take it from there. So I'm gonna, because this is like we're starting a new feature, so I'm going to create a function that's going to be our lightning function, and this function is just an arbitrary function. So far, we have been using these update and like draw functions. We've been defining them and putting them in use. These are like magical functions that dictate Pico-8 program structure. But here I'm just like creating a function of my own. This doesn't mean anything to Pico-8. I'm creating a variable that happens to be a function, and its name is lightning. That's how you can kind of think about like custom functions. It's just like you can store some kind of like value in a variable, you can store some kind of behavior or utility or tool inside of an arbitrary function. So we know that like you know, this is our one like segment of the line, and we're going to be passing an x and y coordinate which is the starting point of that line. And then, right, like all of these other lines are the same exact thing. Like imagine this blue rectangle is like superimposed on the next line segment, and then it will pick a random point, and in that case it picked this one, and then this one, and then this one, and just kind of like keeps drawing that line. So we are starting with an x and a y. That's our x and a y that we are passing to this function. Now, update just has the sort of empty brackets. You don't pass any variables to update. Our lightning function, we do want to pass our starting point, because we're going to be drawing a line to that random other point. X and y don't mean anything here. Like if I were to say print x, this print x here will return null, because x does not exist. X only exists inside of this function, in here, and it refers to whatever we have passed to this function when we called it, right? So if over here we call our function, well, actually we can't call it here because we have not defined it yet, but if we call it down below, you cannot call this function right here, because yeah, you can only call it after you've defined it. You could call it inside of this function, but that's because the update doesn't actually run until all of the code has been loaded, including the definitions of functions that might come after update. So that's kind of like why it works and why it might not. And you may think that you just put, you know, lightning x, y before you've defined it, but you haven't. You haven't done anything of the sort. So I'm going to, this is not the right place to put this. We are going to call our lightning from the draw cycle, right? So let's draw it right below the cloud. So let's put it right here. Lightning. And we want our lightning to sort of like shoot from the cloud. So let's say cloud x. That's our x value. And then y is probably going to be like, let's say 15. And then we'll see if that's a good spot and adjust. Okay, so that's how we're gonna call our lightning function. And then this is where we'll do our drawing business and making all our decisions. So here I'm going to create some local variables that only exist inside of this function. I'm going to call it new x, and I'm going to create a local new y. So these are going to be our random points that we are going to, like, you know, the sort of like a hypothetical point that falls inside of this rectangle. So how are we going to describe the coordinates of this rectangle? There's a bunch of different ways. Well, we want to say like x minus like whatever, however many pixels is 1, 2, 3, 4, 5, 6, 7, or plus 1, 2, 3, 4, 5, 6, 7. And so like I'm going to pick a way of describing this rectangle that will help me tweak the size of the rectangle without having to do too much arithmetic on my own. So I'm going to say random 2 minus 1. So this expression, I'm going to put it in parentheses. Whoops, wrong place. Random 2 minus 1. So this expression will give me a value that is from -1 to 1, because we have told it to pick a random number from 0 to 2, and then we've subtracted 1 from it. And remember that random returns like decimal places, like 3 decimal places worth of a number. All right, so we're gonna, by using this expression, we're gonna get a number range from -1 to 1, and we're gonna multiply this by a number, let's say 5. So this 5 here is basically the total range of this -1 to 1. So this is like -5 to 5, right? So that's kind of how we can describe this jump. And I'm going to do the same thing over here, and I'm gonna copy this part. I'm going to copy the whole of it. And then we have an equally weighted like coordinate system here, because like this is going to equally go left and right because we are doing a random to -1, and this one is going to be equally up and down. So right now, if we were to run this lightning would not prefer to go down. This lightning will just go any which way, and like let's keep doing this. Let's test this out. What will that do? So let's say line, right? Because we're going to be drawing a line, and we want to draw a line from x and y values that have been passed into this function. So it's these guys, right? These guys are automatically defined inside of this function. You don't have to like redefine them or give them values, because they will be given values in right here when we're executing this function, right? So we're passing cloud x and 15. So xy, and then new x and new y. New x, new y. And we want lightning to be let's make it white, right? And so let's see what happens when we run this. Whoop, 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 whoop. It's only shooting in one. I mean, it's like, you know, it's drawing a line, but is this the right line? It doesn't look like the right line. What did we mess up? So, oh, I see what's happening. I am picking a random number that is, you know, from -5 to +5, from -5 to +5, and that's exactly what it's doing over here, because I'm not making these numbers relative to the actual x. It's not that this rectangle is over here, it's just that this rectangle is like over here. So that's my oopsie. You know, it's like around the 0, 0 coordinate of our coordinate system. So that was my mistake. So I'm just going to add it to x and add it to y. So let's see what that looks like. So we're going to have one segment of lightning. It's kind of like shooting from in front of the cloud. All right. So it's shooting for five like lengths. It looks like a good little segment. But let's make sure that it's in the right place. It's like we want it under the cloud. So let's do cloud x plus half of those sprites, which is 16. So it will be like in the center of the cloud, and then let's make it a little bit lower because it was super high. So let's make it at 20. So, you know, so far so good. All right, well, it's just doing a fun little spark in the center of the cloud. Hardly lightning though. So now we're gonna do a really powerful thing that functions can do, and that is recursion. We have created one of these segments, and now we are gonna tell our lightning function to call itself. We're going to call our lightning again, and we're going to start it at the new x, new y. New x, new y. Bam. And so this will keep drawing more lines from that last point in our line. So let's see what will happen. Oh, out of memory. So looks dope. But it crashed our game, so that's exciting. Basically, we don't have a sort of a fail-safe condition for our function. This will just like shoot in any direction forever. So we need to tell it when to stop, right? So we want it to stop when it gets to the ground, and so we do not, like, one way to tell it to stop is to stop creating new lightnings. So here I'm going to say if, it's going to be inside of my new if, and then let me write the condition. If new y is bigger than, say, 110, then don't do this. Oh yeah, so if new y is less than 110, then keep firing. Okay, all right, let's see what this will do. Lightning. Okay, we're still running out of memory, and this lightning is very tight and messy. So let's make our sort of range a little bit bigger, so that the zigzags are a bit longer. So let's do 10 on the y, but let's make it 16 on the x. So let's see what that looks like. All right, well, out of memory again. So we have a condition, but our lightning tends to kind of like shoot like up half of the time, and that is enough for it to about half of the time run out of memory. So like some of the lightning bolts make it to the ground and all is well, but some of them just kind of shoot out into the sky and keep going up forever, and like never do their thing. So how are we going to, we're going to do a little bit of math on this random part here to make sure that we are not equally favoring up and down directions. So this one, we want it to favor equally left and right, because we want it to go left and right however it wants, but we want it to go mostly down and maybe sometimes up. So we want it to go back up only like a third of the time. So this is how I'm gonna write it, right? Is that a third? Well, 0.3 times, whatever that is. That might be a sixth. Yeah, let's say it's sixth. All right, look at that. That's a very handsome lightning. But so far it's just like a single strand of lightning. We don't have that like double lightning situation, or multiple lightning, like splitting the lightning. But that is super easy because we're just gonna call it again. If new y is less than 110, right? So like if we're in this part of the screen, then create a lightning. And then if, let's roll a dice, random is less than, I don't know, less than half, then end. And so less than half of the time, create a whole other lightning that is starting from the same place. So let's see what that looks like. Oh my god. Whoa, that adds up. Oh my goodness. Okay, that's wild. Okay, it's not crashing, so that's something. But let's do a okay, I want it to stop at the end of its lightning drawing cycle. So let's stop it right here, so we can take a good look at it. Oop. All right. Resume. Oop. Resume. Come on. All right. Yeah, this is like just too much lightning, and also like the cloud disappears because we're actually stopping before we're drawing the cloud in the sky. But that's okay because we're just testing. Too many lightnings. So let's make the second one only appear. Wait, this is wrong place. Yeah, so we have it. We have the second one appearing half the time, but let's make it like 1/10 of a time, or appear 1/10 of the time. All right. Okay, that's cool. All right. A little messy, not that messy. These are like flashing a lot. I'm digging it. There's a lot of variety between these lightnings. They're really like happening every few pixels, so we can remove this stop. That looks good. Boop, 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 boop. Boop, boop. So far so good as far as like memory. Like we're not running out of memory. Lightning looks dope. How can we make it a little bit crazier? Because this is like clearly like some kind of X-File situation. Like this cloud has it out for this poor woodsman. So let's give it a little bit of craziness. In the lightning, we're always drawing this line in white, right? But like, what if we drew it in random plus 8? So whoops, plus 8. So random 7 plus 8. So it could be 8, 9, 10, up to 14. Let's see what that'll look like. All right, these are some crazy lightnings. Unsettling. Like both unsettling and charming. All right, I like it. I think there's one more thing I wanna do. I wanna draw a sprite sometimes during the Flash update. Right after we've drawn the map, maybe inside of here. After the map, I'm going to say if Flash, but not every single Flash. So I'm going to say if Flash and random less than 0.2, then end. So here's the first time like we've used this and to sort of like do this wacky assignment of values to variables based on a condition. But here we're using and to create a complex two-part condition. So this expression will only be true if both sides of the end are true. You can also use or, and then they will be true if either side of this condition is true. So like only one of them needs to be true for this to be for it to like run whatever code is inside of this if. So that said, yeah, we want it to be and because we wanted only like 20% of the flashes. I want this sprite to appear. And it's sprite number 218. It's random. I'm gonna like appear this sprite at a random place in the screen, but like on the ground. So it's gonna be 120 plus 4 on the X and random 72 plus random 44 on the Y. So that will place this sprite like it's standing on the ground and it's 1 wide, but it's 3 high. And let's look at it. Yeah. So there we have it. We have covered how to use palette swapping. We've covered transparency and like changing transparency of different sprites and maps, like colors. We've covered conditional statements, like double conditionals, you know, where you have if blah and blah, as well as using and or to assign variables in that short form fashion. We've created some simple counters, two different counters. One is like for the cloud X coordinate, and the other one is for the lightning frequency, and we reset them to a different random value to create like personality to the lightning. And we have created our own like first proper like custom function that takes some parameters and draws a really cool rainbow lightning that is pretty persuasive. This particular function doesn't return any values, it just draws some stuff and then calls it quits. But you could have a function that returns some kind of value into the previous context. So like, you know, random function returns a value. You can just, it's as simple as like telling it what to return. Return, and then you can say new x, new y. Because maybe the previous context, like this one over here, needs that. I'll talk more about that later. It's already like been an hour of me talking, and I'll lop this into a couple of episodes, take a little break, and then record some more of these. Back to the content mines, to mine more content.